Hello everyone, we are Group 5 and I'm Wang Yingxuan. Our presentation topic is WPAN. Here we will introduce Bluetooth and Zigbee. First, let me give you an introduction. A personal area network, PAN, is a computer network for internet connecting electronic devices within an individual person's workspace. A PAN provides data transmission among devices such as computers, smartphones, tablets, and personal digital assistants. PANs can be used for communication among the personal devices themselves or for connecting the higher level network and internet where one master device takes up the role as gateway. A PAN may be wireless or carried over wired interface such as USB. A wireless personal area network, we call it PAN, WPAN, is a PAN carried over a low-power, short-distance wireless network technology, such as wireless USB, Bluetooth, Nearlink, or Zigbee, and range of WPAN varies from a few centimeters to a few meters. These reports aim to provide a comprehensive analysis of communication protocols within WPANs, focusing particularly on Bluetooth and Zigbee. Bluetooth technology is an open global specification for wireless data and voice communications. It is a special kind of proximately wireless technology connection based on a low-cost proximity wireless connection to establish a communication environment for fixed and mobile devices. The Bluetooth protocol stack structure is shown in the figure. The Bluetooth protocol stack mainly consists of the following parts. First is physical layers. The physical layer is used to specify the wireless frequency band use, modulation and demodulation methods. And link layer. There are many things that link layer has to do, such as which radio frequency channel to choose for communication, how to identify air data packets, and what point in time to send the data packets, and how to ensure the integrate of the data, how to receive ACK, and how to retransmit it, and how to manage the control the link. And then, and then is the host controller interference, HCI. HCI is optional. HCI is mainly used when two chips implements the BLE protocol stack to standardize the communication protocols and communication commands between the two. And the logical link control and adaptation protocol, we also call it L2's CAP. It performs a simple encapsulation on the link layer. The link layer only cares about the transmitted data itself. L2CAP must distinguish whether it is an encrypted channel or a normal channel, and it at the same time manage the connection interval. Secure Managed Protocol (SMP) is used to manage the encryption and security of Bluetooth connection here. And the attribute protocol, we can call it the ATT layers, is used to define user commands and command operation data. And generic attribute profile, we can call it GATT, is used to standardize the data content in attributes and use the concept of group to classify the managed attributes. Without GATT, the BLE protocol stack can also run, but there will be problems with interconnection. It is precisely because of GATT and various application profiles that BLE gets rid of the compatibility dilemma of wireless protocols such as Zigbee and becomes the shipment and the largest volume of 2.4 GHz wireless communication products. We will mainly talk about the physical layer in this report. And the table lists some parameters of the physical layer for traditional Bluetooth and Bluetooth Low Energy. The IEEE standards Bluetooth as IEEE 802.50.1, IEEE devices operates in the unlicensed 2.4 GHz ISM band. The symbol rate is 1 million symbols per second. Running in the 2.4 GHz ISM band, Bluetooth employs frequency hopping techniques with the carrier modulated using Gaussian frequency shift keying. And the Bluetooth channel and frequency. The Bluetooth operates in the global unlicensed 2.4 GHz ISM band, spanning from 2.402 to 2.480 GHz, with 79 designated channels, each having a bandwidth of 1 MHz. It employs frequency hopping spirit spectrum technology with 1,600 hops per second and adaptive frequency hopping. We can call it AFM for interference mitigation. Bluetooth Low Energy, we call it BLE, use 40 channels with 2 MHz spacing, including advertising and data channels. Adaptive frequency hopping is utilized on data channels to combat interference and propagation issues. Overall, Bluetooth ensures robust communication in short-range wireless scenarios with a physical layer data rate of 1 million bps. And as for the Bluetooth power level, Bluetooth transmitters have 3 power classes for different communication range. Class 1 with a maximum output power of 20 dBm is suitable for long-range communication up to approximately 100 meters. And Class 2 with a maximum output power of 4 dBm caters to ordinary range device with a range about 10 meters. And Class 3, the lowest power class with a maximum output power of 0 dBm, is reserved for short-range devices supporting communication up to approximately 10 centimeters. Initially, for the modulation, the Bluetooth version 1 employs the Gaussian frequency shift keying, we call it GFSK, as its modulation format. However, as the demand for higher data rates increased, Bluetooth 2 introduced 2 forms of phase shifted keying, PSK, to facilitate the enhanced data rate capability. This transmission enabled Bluetooth 2 to support faster data transmission speed by adopting different modulation techniques. Gaussian frequency shift keying (GFSK) is a modulation method used in Bluetooth communication. Unlike traditional frequency shift keying, GFSK applies Gaussian filtering to the original data before modulation. This filtering reduces the signal strength at frequency other than the desired modulation frequency, minimizing interference between different frequency signals. In GFSK, the carrier frequency is shifted to encode data. The positive frequency deviations represent a binary 1, while negative deviation represent a binary 0. The modulated signal undergoes further splitting using a Gaussian response curve, limiting the extent of the sidebands around the main carrier frequency. This ensures Bluetooth modulation achieves a bandwidth of 1 MHz, with strict filter requirements to prevent interference on adjacent channels. To maintain proper operation, the BT level is set to 0.5 and the modulation index must fall within the range of 0.28 and 0.35. Phase shift keying (PSK) serves as the modulation method in Bluetooth 2. enabling higher data rates achieved with enhanced data rates. Two PSK variants are utilized. The first is the pi quarters differentials called the rater phase shift keying. We call it DQPSK. This PSK variant allows reaching a raw data rate of 4 Mbps, and every different phase shift keying, we call it 8 DPSK, base form of PSK used under favorable link conditions support raw data rates of up to 3 Mbps. Enhanced data rate compatibility is integrated into Bluetooth modulation as an additional feature, ensuring backward compatibility. While the Bluetooth modulations scheme and format aren't inherently suited for higher data rates, Bluetooth 3 doesn't alert the modulation format to achieve higher rates. Instead, it collaborates with IEEE 802.11g physical layers, enabling data rates of approximately 25 million bps. And as for the data link layer, sits above the physical layer and below the interface layer in Bluetooth Low Energy, and the controller aspect of BLE primarily operates within this layer. It outlines how BLE devices are controlled data to transfer, and other functionalities are managed at the low level. Utilizing a state machine, the link layer transmission between various states of BLE based on different events. This approach provides a clear framework for implementing Bluetooth communication as it delineates the progression between different operational states in the system. A host controller interface (HCI) layer acts as a bridge connecting the Bluetooth hardware with the host operating system or application software. Its role is to establish a standardized framework of commands and events that govern Bluetooth operations. This standardized set of commands and events facilitate the seamless control and management of Bluetooth functionalities, ensuring interoperability between different hardware and software components within the Bluetooth ecosystem. And the logical link control and adaptation protocol, see as the figure. L2CAP is like a traffic cop of Bluetooth connection. It helps manage multiple connection between devices, sort of like handling different lines and traffic on a highway. Plus, it's handy for breaking down and putting together packets of data that are flying through the air. Now, in Bluetooth lingo, there's this thing called Bluetooth core specification, a dynamic one. It's like an update and it's some cool new features. One of the coolest update is adding two new modes to L2 cap. Kinda like giving it a new superpower. First up, we have got enhanced retransmission mode. We call it ERTM. Think of it is a soft up version of an old feature. It makes sure your data gets where it needs to go reliably, like adding extra security to your message. Then there's streaming mode. It's a stripped down no frills option. No fancy retransmissions or flowing controls here. It's just fast and simple. Grateful when you need speed over perfections. And get this, even though these modes offer reliability, the low-layer Bluetooth tech still has your back. It can tweak these things like retransmission numbers and flash timeouts to make sure your data stays in order and gets delivery on time. And next, my groupmate Xinshixi will introduce the ZigBee. Thank you.
In the next part, I will briefly introduce the principle of the ZigBee. Let's start with a brief introduction of the ZigBee. ZigBee is an IEEE 802.15.4 based specification for a suite of high-level communication protocols used to create personal area networks with small, low-power digital radios, such as for home automation, medical device, data collection, and other low-power, low-bandwidth needs. It can be designed for many small-scale projects which need wireless connection. And the ZigBee protocol stack can be divided into these 4 to 5 parts, 5 layers. The physical layer is responsible for handling the transmission and reception of data using radio frequencies, supporting different frequency bands and modulation schemes. The media access control layer is used to manage access, addressing the and frame cost control of the communication media. The network layer provides routing and addressing within the network and the forms and maintains the network topology. The application support sublayer facilitates the communication between the network and the application layer and supports variable application profiles. Also in this layer, it has the ZigBee device object for the interface. It manages diverse discovery, binding, and join the network. Next, I will introduce this kind of layer one by one. For the physical layer, it uses the standard of IEEE 804.15.4 and also the ZigBee operates within the ISM frequencies. It usually uses the frequency at 2.4 GHz. From the standard, we know that the physical layer is usually responsible for the following tasks. The first one is that the physical layer oversees the activate and deactivate of the radio transceivers, enabling the ZigBee device to participate in network communication. The second one is for the energy detection. It performs the energy detection within the current channel, assessing the channel quality and aiding in the selection of the most suitable channel for communication. The third one is the link quality indication. It provides a link quality indication for received package, including metrics such as the signal strength and the signal-to-noise ratio. The fourth is that the clear channel assessment is conducted in this layer. Also, it uses the clear sense multiple access with collision avoidance to ensure efficient channel access. The fourth one is that the physical layer is responsible for selecting appropriate channel frequency to minimize interface and optimize our communication quality. In this application, ZigBee choose 2.4 GHz. The sixth one is that the transmission and reception of data are managed by the physical layer, and it involves the encoding, the modulation, also the demodulation process. So for the next few minutes, I will introduce the modulation in this physical layer. The physical layer modulation is based on this standard and it operates OQPSK for the 2.4 GHz signals and the BPSK for the 800 to 900 millihertz signals. Also, this physical layer specified formats for the physical protocol data unit that include Primple, start of frame delimiter, and also the length and the contents of the MAC protocol data units. This is how the modulation works. For the OQPSK, it maps every 4 PPDU bits into one sample. The 2.4 GHz in the 2.4 GHz, the OQPSK spreads every sample to a 32 trip sequence. Then the trip sequence are OQPSK modules and pass to a half sign pulse shape filter. This is how it works. And for BPSK, every resulting bit is spread to a 15 trip sequence. Then the trip sequence are BPSK modules and pass to a normalized cosine filter. Next, the second layer is the MAC layer. The MAC layer sublayer is prime task with managing access to the physical radio channel, and it has following functions. The first function is that if the device operates as a coordinator, it's responsible for generating network beacon, facilitating network organization and synchronization. The second one is that the device synchronization their operation to network beacon, and the third function is that the MAC sublayer facilitates the association and the dissociation of the device with the personal area network is the PAN, enabling diverse connective and network management. The fourth function is that it supports diverse security measures. The fifth also in this MAC layer, it has the CSMA-CA mechanism, which helps prevent package collision and ensure the efficient channel unitization. The sixth function is that the guaranteed time slot mechanism is managed and maintained by the MAC sublayer. It provides dedicated time slots for specific devices to transmit data, also enhance the network efficiency and the timeliness. The last function of the MAC layer is that the MAC layer establish and maintain reliable communication link between pure MAC entities, ensure the data delivery and the integrity within the network. The third layer is the network layer. The main function of the network layer is to ensure the MAC sublayer is used correctly to provide the appropriate interface to the next layer. Also, it establishes network, assign addresses, and add and remove diverse. Also, the routing protocol used in this layer is the AODV. It's broadcasting a load request to all its neighbors, and it's the neighbor then broadcasts request to their own neighbors until they reach to the destination. Once the destination is reached, a route reply is sent over the transmission back to the source following the least cost path. Once the source receives the reply, it updates the routing table with the destination address in the next hop in the path. The fourth layer is the application support sublayer. The main function of this layer is that it keeps up-to-date binding table in the forms of dataset, and this can be used to find appropriate drivers depending on the service that are needed, and those are different service offers. Also, it is in this layer, it has an object called the Zigbee diverse object. It is responsible for overall diverse device management, security keys, and policies. That's the introduction of the Zigbee. And in the previous presentation, we have introduced the Bluetooth and Zigbee. Both of them each have their own unique advantage and application. For the Bluetooth, it's excel in application scenery that require high data transfer rates and broad diverse compatibilities. And it's popular for consumer electrons, also audio headsets. And on the other hand, Zigbee is used in applications that require low power consumer consumption and long battery life. While both of those technologies offer a solution for a variety of the case, they also face a challenges such as interference and security issues. That's the conclusion of our presentation. Thank you for your listening.